Okay, let's continue. From part 6, we just reached the definition of the compound, right? And then, so we start from there, we left off. Now let's give you a detailed definition of compound, right? What is that? It is the defined as the substances composed of atoms from 2 or more elements, and those atoms, they have a definite proportion of mass in between each other, and also a constant integer number of mole ratio, which is the subscripts for a compound formula, right? At the lower right hand subscripts. And then they are bonded, those atoms bonded with chemical bond, either single bond, we call sigma, or double bond with sigma or pi. We use a stick and a ball type symbol. The stick means the bond, and then your single bond is 1 stroke, and then double bond is like equal sign, triple bond, three strikes. Alright, so the bond or the combination of all, if the complicated molecules or compound, they are formula, right? So if we understand that, then we at least understand if the compound, right, should have at least 2 or more elements involved, not just molecule. Molecule can be compound molecule, and it can be molecule without the second type of elements, which is only one element we normally call what? Diatomic, right, or monoatomic, triatomic, or polyatomic molecules. There's only one element involved. We discussed in the previous part 6. Now today we are talking about a compound involve more than 2 elements. So what are we going to use an example to expand that? Now you have my notes on page 4. On page 4, there's table 1-2 on page 4. It's called the mole ratio, which is the proportionality on atoms of various elements in compounds. Now here I'll shorthand a little bit. Mole ratio of atoms of various elements in compound. Now those, there are about 13 are listed down there. Every one of them are common chemical compound, and then we routinely were in contact with them. For instance, methane, right? First one we already talked about, we don't use it. It's called a natural gas. And the second one is gasoline, it's CaH8. So let's say, let's pick one, the C8H18. That's gasoline, right? That's gasoline, and it's called octane. And then it has a definite proportion for 8 carbon atom plus 18 hydrogen atoms, correct? And the hydrogen weighs, right, the mass is 1.0078 AMU, and the carbon is 12, so you have definitely have a definite proportion of mass between those 8 carbons add all together and 18 hydrogens all together will be have a definite ratio for their proportion of mass. And also they have a constant integer number of mole ratio, which is the subscript right here, 8 to 18. So in one molecule of octane, the gasoline has 8 carbon atoms combined with 18 hydrogen atoms. If we talk one molecule, that's molecule. And if we talk about 1 moles of octane gasoline molecules, then we are talking about 8 moles carbon atoms included, which is 8 times Avogadro constant, right? And 18 hydrogen atoms involved. So that's 18 multiply Avogadro constant, 6.022 multiply 10 to 23rd number of atoms of hydrogen multiply 18, and then that's the same multiply Avogadro constant, multiply 8. That's the number of moles of carbon atoms and number of moles hydrogen atoms is in a integer number ratio, which is presented by those subscripts. Okay, that's the one. Now number 2, right? And then we picked up those, and then we find ethanol, right? Ethanol is a alcohol, right? If it's pure, it's ever clear, and it has 3 elements involved. Here is oxygen right here, and it's carbon and the hydrogen we got a total 6. Even though we separate them for one H with one oxygen, because OH is hydroxide, and that is the function group of alcohol. Every alcohol has one or more OH, right? Has a charge of -1, because why? Oxygen is -2, 2 minus charged, and the hydrogen is +1 or 1 plus charged, right? Cation. So they combine, give you total net charge is -1, 1 minus. So you have how many? So you have two carbon atom plus, right, 6 hydrogen atom plus 1 what? Oxygen atom. Clear? Now if you talk about the number of moles, that's the mole ratio. 2 to 6 to 1, right? We already listed on my table. At the end I said mole ratio proportionality is 2 to 6. Here's 2. Let me make another column. May still have enough space, right? So we are able to understand this is a very important concept. 2 to 6 to 1 mole ratio, right? The mole ratio right here. Now the third one we can use what? Let's choose sucrose, right? Sucrose, C12, right? C2H22, oxygen 11, right? Here should be column, right? All right. So you have what? You have 12 carbon atoms inside one molecule, plus, right, 22 hydrogen atoms in one molecule, and 11 oxygen atoms inside this one molecule. So the mole ratio between carbon, hydrogen, oxygen would be 12 to 22 to 11. Clear? All right. So that's the. Now that's fixed. It's called what? It's called a constant integer number of mole ratio right here. Right. The mass also, of course, right? 11 or 22 hydrogen will be 22 AMU, close. Right? 11 oxygen you times what? Times 16, right? So that's going to be what? 176 AMU. And 12 carbons, what? 12 times 12 is 144. So 144 AMU to what? 22 AMU to 176 AMU. That's a definite proportion of mass. But when we talk about the number of atoms, that's a 12 carbon atom, 22 atom of hydrogen, and 11 atom of oxygen. And the number of atoms ratio, that's exactly equal to the mole ratio if we talk about 1 mole of such compound sucrose. And then that will be 12 mole, 22 mole, and 11 mole of each of these 3 elements. They are atoms, and then in number of moles. That's the integer number of mole ratio, right? So let's pick up 1 more, not too many, that's too much, right? So, the last one, did I use Epsom salt last time? I did. So let's choose another compound, copper sulfate and pentahydrate. So copper sulfate. Now penta is 5 hydrate, right? So this one is a compound. It's ionic compound. Now this all 3 consider as molecular compound, right? They're organic compound. The molecule, they have a lot of covalent bond there, all right. And then they have a very small one. It's a ionic bond between the hydroxide and then the rest of the components of alcohol. But here is not. Here is now this is not a single ionic molecule. It is an ionic molecule on the front with a copper sulfate plus 5 crystal water attached to the crystal structure of the copper sulfate and embedded there, and it's very weakly bonded, not strongly bonded. So they make this kind of formula with a dot. That's the second time we talk about it. In part 6 or part 5, we already mentioned that already. We use Epsom salt, which is 7 water attached, and these 5 water molecules can be easily dehydrate or separate from the molecule, and then there will be evaporate temperature of the compound under more than 100 degrees Celsius. So the water boiling point reached, and then water will boil off, evaporate off, and the color will change. This compound is a very beautiful blue color crystal, beautiful blue. All right. I wish our ocean color would be as blue as this compound, but it's not. All right. And then you heat it, and then these 5 water molecules evaporate out, then become white powder. Now, white powder, what do you talk about white powder? Is that white powder? Go where? Go to your nostril? No, that's a different white powder. We talk white powder is the white powder come from dehydrate. It's called anhydrate, right? Copper sulfate anhydrate. There's no water involved. So this one, let's talk about how many copper is metal transition, right? Number 29. On the periodic table, right, it has 2 oxidation states. One is +2, one is +1. The +2 is more reactive than +1. We get into the reactivity series in the future. We get into the metal, all right. But now here, we get you to a little bit, to expose you to a little bit, so you have some kind of vague impression, and the second time you picked up, it's much easier, all right. That's my way of teaching. Okay. Here we say copper sulfate. So 1 copper, right? 1 copper atom in 1 molecule, and then plus what? Plus how many sulfur? 1. There's no subscript. The subscript is there's 1, but we omit it, right? So that's the sulfur is 1 sulfur plus how many oxygen? 4, right? Oxygen, and the plus keep on going. What? We have more. 5 times 2, 10. 10 hydrogen plus what? Another 5 oxygen. Total is going to be 9 oxygen. So 5 oxygen. These 2 made 9 total, right? So if you talk about the pentahydrate, right? The pentahydrate will have the number of atoms in the ratio as integer number of atoms. The ratio is going to be 1 to what? 1 to 9 oxygen to 10. Is that correct? 10, yeah. Oh, sorry. 10 what? 10 hydrogen, right? But if you talk about 1 mole of this compound, right? Pentahydrate, copper sulfate, and then you have, right, you have what? 1 mole of copper atoms, which is exactly 6.022 multiplied 10 to 23rd Avogadro constant. Number of atoms of copper, same as sulfur, 6.022 times 10 to 23rd Avogadro constant. And then 9 times 6.022, 9 moles, and 10 moles of what? 10 moles of hydrogen, right, atoms. So 10 times, so what is that number? 6.022 times 10 to what? Instead of 23, 10 to 24, because 10 times bigger, right? You add 10 to 1 as the second term in scientific notation, right? 10 to the power, right? Power to 10. So that's how we understand. So these are including, you know, most of the compound we're going to in touch with, and in the next part of this section. All right. So that is definition. We get some examples, and then we go by the definition. We fit into there very well, right? Very well. Now the bonding. The bonding we're not talking about here yet. Now in separate compound, we may have a single bond or double bond or triple bond, but we're not talking until that point. We're going to get into it very soon, right? Very soon. Now, so this is the sample. Now, what is type of a compound, right? Type of compound. Now that's just in general, right? So types of compound, right? Now we have a compound all the way start from two different elements. Their atoms combined with a fixed or constant composition, right? And we call integer number mole ratio. That's composition. That's composition based on the number of atoms, right? That's chemistry. We don't go beyond that, and we stop at atom level, right? And then we have how many types? We can have more than millions of compounds, but within all these millions of compounds, we are able to categorize into barely 3-4 different types. Now, first type, there's too many of compound coming from or made or composed of only two elements, right? We call what? We call binary compound. Binary means two elements only, right? Two elements. So we're going to talk about two, but within the category of binary compound, we're two kinds, right? One is we call ionic compound because they basically formed from the metal elements, the atom from metal elements, combined with different bonding, most of the time a single bond, sigma, with a non-metal, atom from a non-metal element. So if we never had a picture about the distribution of metal elements and the non-metal elements on the periodic table, now it's time to give you a small review. So this space, I'm going to use this space to quickly draw a shape of periodic table. So periodic table will start from the hydrogen, right? So on the left, right? Here's going to be the hydrogen, right? And then the second family, right? This is a 1A, that is 2A, right? And then we have 1, 2. Now here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up here, we are able to make another region, and that is 1, 2, 3, 4, 5, right, 6. So here will be two columns, right, and here will be another column. That's noble gas, right? Noble gas. Here basically are three periods, right? Three periods. 1, 2. Of course, there are another two group of internal transition metals, right? It's called lanthanide and actinide, but we're not going to get in there. Right? So that's the periodic table, right? So here is hydrogen, the lithium, right? And the beryllium, right? Here's boron, that's number 3A, right? That's number 4. Let me use the top so it won't confuse. No, that's number 6. That's number 4A, number 5A, number 6A, number 7A, and the number 8A. Now this is B group, right? We said B group transition metals, right? Or we call heavy metals. Alright, we're not going to touch too many of them so far. Now here, lithium wood, next to wood. Sodium, right? Sodium wood. Magnesium, right? So here, potassium, the calcium. Number 20, we already studied in detail. I'll give you color chart made, right? You should get familiar with it. Boron is the third, and then 4th is going to be carbon, right? And this is going to be nitrogen, oxygen, and fluorine. Here's a helium and a neon, right? Here's aluminum, right? Aluminum, silicon, right? Phosphorus and sulfur, chlorine, and argon. Now that's the first 20. All right, that was 20. Now in this periodic table, now we have not talked about the distribution of the elements in their characters as metal or non-metal. Now this periodic table, you can just basically you can cut them all into 3/4 and 1/4, almost like this. So, but there is a line we call the line called stairway line, under the box of B, boron, and then go between aluminum and silicon. I use blue. The blue is not really showing too much different. And then under the silicon, and then go vertical, and then keep on going like this. And then it says boron is semi-metal, and which is metal. It has a properties fitting to both metal and non-metal, and then the silicon may be also considered as a semi-metal, and so on. But that's only 8 in the textbook. Most of the textbook only lists 8. But to me, it should be double. I would introduce this to everybody in my class. Those elements with their box in the periodic table, as long as the corner of its box touch this stairwell line, those elements all have both metal and non-metal properties, should be considered by definition as semi-metal or metalloids. All right. Just for a simple example, carbon and aluminum. All right, carbon and aluminum. These two, one is considered as non-metal for almost 100% of textbook or chemists. They forgot the definition. You learn science, very picky. You buy definition. Semi-metal, metalloid means what? Metalloid means it has property for the elements, has property. Some of the property only metal have, and some of them only non-metal have, right? So if they have both, they got to be considered as semi-metal or metalloid. Look at carbon, right? Just use carbon. How many natural forms for carbon? Carbon has 3 natural forms. One is diamond, the hardest, shiny and beautiful, right? Every lady wants one, right? One day in her life. And then the second is what? Graphite. And the graphite is what? We use every day in classroom, right? That's a pencil. We write notes, right? Look at graphite, shiny. Have you ever seen tip of pencil? It's so shiny. So it has a metallic luster, like shiny, like gold, silver, right? And also, the carbon has another form of charcoal. The coal, the charcoal, you cook barbecue with. It's ugly looking, soft, mushy, ugly, and powdery. It's very, 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 very non-metal, right? But all these 3 natural forms already show the carbon can be one of these 3, and it can show either metal property or non-metal property, or in between. So if it's in between metal and non-metal, you got to define this carbon elements as semi-metal, not non-metal, right? And then if we talk about compound, we talk about they combine the atoms from 2 different elements. If they form ionic compound, we're going to put down the ionic compound, right? Type 1, let's say ionic compound. Oh, this is blue. Let's use black. Right. Ionic compound, ionic. Then inside ionic, they have 2 kinds. One's ionic, one's ionic binary compound. Another one is, oh, there should be binary compound. Let's just put a binary compound. Binary. Binary compound have a ionic, right? Ionic type. And we talk about ionic compound. It got formed by the ions, the cation and anion. They attract electronically, right? Electrostatically, to form a strong bond in a crystalline structure. They are very strong. For instance, table salt NaCl are said its melting point is 801 degrees Celsius, 1400 something Fahrenheit. Very high. Why is it so high? Because the attraction between cation sodium and anion chlorine are so strong, require so much energy to break the bond and put them separate, become ions. Alright? So that's why it's required. So if you talk about those ionic compound binary, and you need non-metal and metal, one group metal, they all form positive charge cations. So from the stairwell line, the blue line, to the left, entire period table, they are metals. Transition metal, alkaline earth metal, the first, second column, first family, second family, and then boron family, except boron, the alumina, they consider as metal, and then of course, right, as metal, gallium, germanium, and all this metal, but along this line, actually has two. Now, not only the natural form, let's go back to semi-metal. Semi-carbon. Carbon not only has a three natural form representing metal and non-metal both, electronically, right? It is also what? It's conductive, right? Graphite is conductive. So, you see those products made to cover the reciprocal on the wall in the room? Because they're afraid about the kids stick some metal wire into the reciprocal and holding the hand and short through their body and kill them, electrocute the babies, right? So they put some plastic cover. But it happened. It happened to my best friend and his son. He was like 2 or 3 years old. Came to the United States. They live in LSU, Mary student housing, and the couple went to school and go to work. And the son kept home by himself. Of course, that's going to be arrested. The parents do this, but now they didn't know. Nobody knows that. And he was making all of us. One day he put 2 pencil lead. He put long pencil lead sticking to the reciprocal. And there's a paper of those Mickey Mouse, whatever the prints on top of it, and it caught fire. The fire goes to the roof, and it goes smoke. And the fire brigade was called upon for that day. They came over to see the kid was inside the room and the house burned up. Because why? Because he put graphite into the reciprocal and the touch, and then accidentally caught fire, and then set the room on fire. So the carbon, which is a graphite, is one of the form of graphite, right? It's electric conductive, very, very good electric conductor. Right? Very, very. And diamond, I don't think it's an electric conductor. You can put a piece of diamond in between the reciprocal of 220 or 115 volts. It will not give you current go through. So that's non-metal. So it both metal, non-metal, carbon, and the Bible we introduce another concept we call what? Oxidation states. What is oxidation state? Oxidation states is when the compound, their element in the when the elements, their element in the compound form compound, they may show the ability of take electron over, become negative charge, or give electron away, become positive charge, ions with a charge. So the carbon is at what? 4 major, right? It has what? We always said the carbon has a +4 and a -4. It's on both sides of a zero of neutral. Right? Could be negative as anion, could be positive as cation. So carbon is a semi-metal, not non-metal. Right? So we talk about here, then we talk about ionic compound. The ionic compound form from what? Ionic compound form from what? From the atoms, right? From atoms. Right? Atoms of metal elements as positively charged cation with, right, the normally non-metal elements on the right hand side of this corner, 1/4 of the numbers or less, and then the non-metal elements as negatively charged anions in ionic bond in the crystal. Okay, the time is up. Alright, we continue from here.